Hi, my name is Haki Benita. I'm a DBA, a developer, and I currently lead the development of a large ticketing and payments platform. So during my professional career as a developer, I had a chance to work with many different types of people and on many different types of projects. I worked with different types of developers, front-end developers, back-end developers, ETL, BI developers. Also had a chance to work with different staff members, for example, support, operations, compliance, and security officers. I also had a chance to work with management at different levels. I worked with project managers, product managers, CTOs, CFOs, CEOs. And one thing that I always thought was very interesting is that many of these people have access to information inside the organization using SQL at different levels. So, for example, developers access SQL databases from their programming language or directly from the terminal. Analysts often get access to the database to fetch data into pandas data frames and to build their models. Staff members usually get access to SQL from reporting tools that they can customize or maybe fill with the parameters. Management sometimes get dashboards and visualization reports to help them make decisions based on data produced from these reports. So SQL is increasingly important in giving access to different people inside the organization. So it's a very important thing that people inside the organization, we know how to use SQL correctly to produce correct results that they can make good decision based off. So in this presentation, I want to share some common mistakes in SQL that I saw in code reviews and when I reviewed reports from different people that I've worked with. So to illustrate some of these mistakes, we're going to talk about an imaginary retail chain with branches in New York and LA. The chain sells to customers that can either be members. These are customers that I know their name, maybe they signed up in advance. And we also have some walk-ins, that people off the street that we don't know. We also give special discounts on some of the products, and we also have some products that we give away for free. So this is what the data looks like. We have a lot of data inlined here. I know that some of you may think, oh man, this is not normalized, but for the sake of discussion, this is fine and this is good enough. You can see that we have the branch here. We have New York and LA. We have the time the sale was made, the customer. When the customer is unknown, it's marked with null. We have the product, the price, and the discount. So let's create some simple sales reports, the types of reports that you probably create on a daily basis, and see what can possibly go wrong with these reports. So to kick off, let's produce a report that finds the discount rate on shoes. So we might write this query to select the price, the discount, and divide the price by the discount and multiply by 100 to get the rate, restrict to shoes only. And this is the result that we get. So many people will stop here and say, we got a result, we give a 0% discount and bid down and call it a day. But is this correct? I mean, is this number correct? We previously saw the data and we know that we give out discounts. So a 0 discount rate is probably incorrect. So let's see what happened here. When we divided the discount by the price, we divided two integers. And when you divide two integers, the database would truncate the result. As we can see from the first example here, when we divide 1,000 by 10,000, we get 0. But if we cast one of the sides to float, we get the actual number that we were looking for. And if we multiply this by 100, we get the percent, which is 10%. This is what we expected. So we can now adjust or fix our query from before to actually return the discount rate. So this time we cast one of the sides to float. In this case, it's price. So discount divided by price casted to float gives us the discount rate that we were expecting. Now, I want you to notice that we did not get any exception. We just got incorrect results. So an innocent user might think that we actually provide 0 discount rate if he's not aware of this behavior in SQL. Let's look at another report. This time it's a bit different. We want to find the average discount rate by product. So we take the product and we apply an aggregate function, AVG, on the discount divided by the price. We already know that integer is truncated, so we cast price to float and we multiply the result by 100. Now this time we actually get an error. The error we get is division by 0. This is happening because, if you recall, we have one product which is called giveaway, that the price of this product is 0. So when we divide the discount by the price, we actually divide by 0, and the database is warning us that it cannot handle this case, and we get a division by 0 error. To guard against division by 0 errors, we can use a function called nullIf. It's a very useful function, and it uses a very useful behavior by the database. When you perform arithmetics and one of the sides of the equation or the expression is null, the result of the expression is null. So in this case, we want discount divided by 0 to actually return null. We can do that using nullIf. NullIf accepts 2 arguments, and when the first one equals the second one, the function will return null. So here we want to return null if the price is 0. This will make discount divided by the result of nullIf to be null. We can see in the table below that when we divide by 0, we get a null discount rate. Now, if this is a result we are satisfied with, if we think that it makes sense to have a null discount rate and our application can handle it, you can stop here. But for completeness, if you actually want to have some type of number when the result is null, you can pair this expression with another useful function called coalesce. Now, I'm not sure what is the right way to pronounce coalesce, so I'm just going to call it coalesce, and you can check it up later. But this function is very useful because it accepts an arbitrary amount of arguments and it returns the first argument, which is not null. So here we can use coalesce and put our expression as the first argument. And if it's null, it will return the second argument, which is 0. And once we tied everything up together, we can get a full report and see that, for example, the discount rate on giveaways is in fact 0, which is what we want. Let's move on. How many unique users purchased each product? This is also a very common report that I'm sure that you do some variation of it. And this time we used an aggregate function count paired with distinct because we want to find the unique users that purchased each product. Once again, we get the result, and we need to be very careful with it and actually see if it makes sense. So in this case, we got a result that says that we had 0 customers purchasing a hat. So we obviously have a row in the table for a sale of a hat, but the result that we got here is 0. So is this correct? Does it make sense? Can we explain this result? The reason for that is that aggregate functions ignore null values. So if you are unaware of this fact, you can easily get simple reports very incorrect. So just to illustrate this behavior, let's look at the results. Let's compare the results of count star, which counts the rows. You can see it here. And count of a specific field, which in this case is customer, and it's nullable. So you can see in the result that some of the products return different numbers because they were purchased by unknown customers where the customer was not. So you need to be aware of this behavior. And once you are aware of this behavior, this can actually be pretty useful. You can use this fact to create reports, but this time you actually know what you're getting and you know how to explain the results that you got. So if, for example, we want to find the number of members or known users that purchased each customer, and we also want to get the number of unknown customers that purchased each product, we can subtract the two and get results that makes sense. So keep in mind that aggregate functions ignore null. This is not only count, also sum, average, standard deviation, and other functions that you may use on a daily basis. So if you use them with a nullable column, you need to be aware of this and probably adjust your query accordingly. So next up, we are going to imagine we have a reporting tool and we want to create a reusable query to find the sales made to a specific customer. So I'm going to use PSQL syntax here for the variable. This is this one over here. I want to get the sales made for a specific customer by its name, okay? So just to illustrate how this query may work, I can set the variable name to Bill. And if I run this query from before, I get the sales made to Bill. So this is fine. This makes sense. This is what we want. But what if we want to find the sales made to unknown customers? Let me remind you, for unknown customers, we don't have a name, so the name is null. So in this case, if we execute the query with the name set to null, we get no rows. So once again, no exception, no error, but we just get incorrect results or maybe unexpected results. So the reason for that is that nulls behave differently than literals when compared using equality. So to illustrate, I have this table here that you can see it can be a bit confusing, but you just need to remember that null does not equal null, null is null. As you can see, if you use equality with a nullable value, the result of this expression is null. If you want to compare two nullable values or compare a value to null, you need to use is. So if we want to adjust our query to handle both cases, both when we have the name of the customer and when the name of the customer is null, we need to draft this complicated condition. We first handle the case where the name is null, and then we use is. And if the name is not null, for example, Bill, we want to use a simple equality to find sales made to Bill. So if we try this out, we can see that it's working. On the left, you can see that we set the name to Bill. We run the query and we get Bill's sales. And on the right here, we can set the name to null. And unlike before, we now get results. So these are the results of the sales that were made to unknown customers where the name is null. So this is a very complicated condition. As you can see, I'm sure not all of people can think about it, be aware of it, and actually draft this query successfully. Also, when you have a lot of other condition and other parameters, this can get messy very quickly. So there must be a better way. In fact, there is a better way. There is a special operator to compare nullable values called is distinct from, and it has a sibling operator called is not distinct from. If we replace is not distinct, the equality from the query before with is not distinct from, we can get actually correct results or expected results. The nice thing about is distinct from is that it treats null values like a literal, so you can compare them. So if we look at this table below, we can see that, for example, when 1 and b both equal 1, the result of equality is true, and the result is of not distinct from is also true. If we look at the third case where A is 1 and B is null, the result of the equality is null, but the result of is not distinct from is false, which is what we expected. In the bottom row, you can see that when both A and B are null, the result of the equality is null, which is what we've seen before. But the result of is not distinct from is true, meaning null equals null, or null is not distinct from null. So this is a very useful operator to use with nullable columns. So the next time you write a reusable piece of report, if the value is nullable and your reporting tool allows it, you can treat it with is not distinct from. Okay, moving on to some date ranges in SQL queries, which is also a very, very common report that we also make all the time. Let's try to find the amount of sales during each month. So I'm sure that a lot of you might actually write this query. You use dateTrunc, which is a function that accepts a period and a timestamp and returns the truncated date. And we just sum the price and group by the first argument and the first expression. And we get this result. So this is once again an innocent looking result. We didn't get any exception. We didn't get any warning. We just got a result. So we can easily take this result and go make a decision based off this result. Just imagine you're a CEO of the large chain and you need to decide whether to close a branch and fire lots of people based on the result of this report. Are you really signing off on this report without investigating further? So let's see how this can get wrong. Remember, we have branches in New York and we have branches in LA. So if I'm the CEO and I'm calling 2 analysts from the branches to show me some data, if we run this report in New York time, we get the results on the left. If we run the exact same report, but this time in LA time, Los Angeles time, we get an entirely different report, different information. So I'm the CEO and I'm trying to make a decision, but I get conflicting information. So how am I supposed to reach a decision? So this is very, very dangerous and actually very, very common mistake. And this is actually a mistake I've made a lot of time myself when I was unaware of the time zone set by my client application. So date times are in fact very, very hard. You need to consider time zones. You need to consider daylight savings. You also need to be aware of the database type. Sometimes it's date, sometimes it's timestamp, sometimes it's timestamp with a time zone. So there must be a better way to deal with dates and times. And in fact, there is, because the database is handling most of it for you. You just need to be aware. And my recommendation to you is when manipulating timestamps, you just need to always be very explicit about the time zone. So these are just some of the mistakes I encounter a lot. So we already saw the dateTrunc. So in our example, we just used dateTrunc month on a sold date, and we didn't know or did not realize what was the time zone when we executed this function. So we got unexpected results. But if we are explicit about the time zone and we use at time zone New York, we get expected and consistent results. There are other functions like extract and date part that takes out a part of the date. For example, extract hour gives you the time of the day, and date part does the same thing. And when working with actual hours and minutes, it's even more dangerous because different time zones can yield completely different results. Another common mistakes I see all the time is people converting or casting time zones to dates. This is usually to get a nice format in Excel because it's easier to convert an ISO daytime to ISO day to a date type in Excel. So they just throw in this cast to date, not realizing that they may get inconsistent results if they happen to fall on a time where the time zone may change the actual date. Another example is when the date is provided explicitly. So it's better to just add the time zone bit at the end. So this way you can be sure of the time zone that you operate in. So let's look at another example. And now we are all smarter. So now we want to check what is the busiest hour of the day. So now we use extract, and we know that we need to be very explicit about the time zone. So we set it to New York time and we produce this report. But is this correct? I mean, we did everything that you said, right? Aki, you said to set the time zone explicitly, so we did that. But in fact, this is not correct because we have two branches in our chain. We have one in New York and one in LA. So 4 o'clock or 10 o'clock in New York is not 10 o'clock in LA. So this is an example where the time zone, the casting to time zone is a bit more complicated. We need to use case here to extract the sale date according to the branch. And you can see that we get completely different results. Previously, we got that 10 is the busiest hour of the day in our chain, and now we know that it's 11 at night. So let's look at another type of report that is using date. Dates are very dangerous. I have a lot of examples with dates. So let's try to find the number of sales that were made in March. And once again, I'm telling you, be explicit about the date time, and I want this report in New York time. Let's say I need this for my billing cycle and I want this in New York time. So you use a count to fetch from the sale table, and you restrict the date from March to April, and you do that in New York time. So in March, we had 9 sales. Now I want the numbers for April. You run the exact same report with different parameters and you get 7. Now, is this correct? Just to make sure, let's try to find how many sales are there in total, and we get 15. So we got 9 and we got 7, which is a total of 16, but we only have 15 rows in the table. So one row is counted twice. This is because between is inclusive. Okay, we had one sale that happened at exactly the 1st of April at midnight in New York time. And when we used between on the range, the 1st of April appeared in both, so it was counted twice. Now, I know you might think that this is a very unlikely scenario where a sale is made at exactly midnight on the 1st of April at New York time. But in fact, if you have an automated process, for example, that creates sales in batch, it's not unlikely to imagine that it's creating it at exactly this round hour. So my suggestion to you is to avoid between and instead use half-open ranges that do not overlap. So in this case, we replace between with greater than equal and lower than. This way, the results from the 1st of April at midnight do not overlap. And we can see that before we got 9 and now we get 8, which is the correct result. Another example where between can provide incorrect or unexpected results is not restricted just to timestamps. I've seen it happen with integers and floats as well, most commonly when you use it for binning or bucketing or to create a histogram. If you're using between, values can overlap and fall into multiple buckets. Also, when using dates and not just timestamps, this is also very common. In this example below, I'm looking for 90s babies. And this square will actually include babies that were born on the 1st of January 2000, which is not what we meant. So just a quick recap of what of the common mistakes we've seen so far. So first, you need to be especially careful when dividing integers because the database will truncate the results. So you need to cast one of the sites to float. You can guard against division by zero errors using null if and coalesce. You can also you also need to be aware of the fact that aggregate function ignore null values. If you understand that, it can also be very useful, but just make sure that you understand that. Next, you need to be careful when you compare null values. You can use is distinct from to treat null like a literal value. And finally, dates and times are hard, so be extra careful around timestamps and always be explicit about the time zone, and keep in mind that between is inclusive, and use half open ranges when appropriate. So far, we've talked about mistakes that can produce incorrect results, which are very, very dangerous because sometimes you don't even get a warning or an error. But I also think that slow queries are also somewhat dangerous because first, they can consume a lot of resources for no reason. And second, it's very frustrating to work on a slow query. So I want to focus on one thing that I've seen that prevents the database from optimizing queries, and that's transformation on indexed fields. So if you have a field in the table and it has an index on it, if you apply a transformation on the field, it can prevent the database from using the index. Now, keep in mind, I'm not talking about function-based index. I'm talking about plain indexes, which are usually the case. And I want to show you some examples, some common examples of how transformations can prevent the database from using indexed fields. So simple arithmetics, for example, can prevent the database from using an index field. You can see that in the first example, I wanted to filter on the indexed ID field, which happens to be the primary key. And if I do ID plus 1 equals 100, it does not use the index. And when I just move the plus 1 to the other side and do ID equals 99, I can use the index and I can see improvement of around 50 times faster. Another example is when you set the time zone, as we've seen before. On the top query, we set the time zone on the indexed field, and the index is not used, and it completed in 60 milliseconds. On the bottom, we actually moved the time zone to the right-hand part, and so the index was used. And once again, you see a major improvement in the query runtime. Also, date arithmetics using the interval, just like plain arithmetics with numbers, date arithmetics also can prevent the database from using the index. So once again, you can see a big speed up. String manipulation, that's the usual suspect. This is an example from a login page. Instead of applying lower on the literal value, you apply it on the field and prevent the database from using the index. So the bottom version is better. You just need to make sure to keep the data normalized in the database. So emails in the database need to be stored in lowercase. String concatenation. This is also a very common mistake when developers often do when they add search functionality on some users table. If possible, it's always better to split the condition to two separate conditions, or create an appropriate index, or maybe you just have a modeling problem. Another mistake I want to talk about that I see very often is people mixing union and union all. There is a difference between union and union all. Union all concatenates the results, and union does the same, but it also removes duplicates. Removing duplications can be a costly operation. So you should probably avoid it if this is not what you want. So union all is a bit longer, but it's actually faster if you don't need to remove duplicates. And finally, sometimes it's useful to keep in mind that null values are not indexed. So in our sale example, if we are looking for customers who are unknown, it will trigger a full table scan. So This can either be a data modeling issue, but maybe if you educate your users on how to use the database or how your indexes are looking, you can make them write SQL better. So this is it. Hopefully you enjoyed this talk and got something out of it. You can check out my blog, akibenito.com. You can also look me up on Twitter and subscribe to my newsletter. Feel free to contact me if you have any comments or questions about this presentation. And this is it.